everyone, and welcome to our final project presentation for CS3215 Human-Computer Interaction. We are Group 4 from PSCSPA together with Carlo and Remar MALANON. I am Guiller Angelo Hermoso, and today we are proud to showcase our UI/UX redesign of the BIR online registration and update system in the PorTaxPH. We have structured our presentation into 3 specific segments: an overview of coding environment, a live system walkthrough, and a design comparison.
To kick things off, we will start with a short walkthrough of our source code. This segment is to confirm that our UI/UX redesign was genuinely coded manually rather than being assembled through a drag-and-drop builder. We use the Flask framework to build this application. Flask is a lightweight Python web framework that allows us to create a robust and scalable backend. It handles the routing, which means it directs the user to the correct page when they click a link or enter a URL. To make this project professional and maintainable, we wrote a custom script called instructor.py, which is located in the tools folder. Since initially, the project had all its HTML, CSS, and JavaScript mixed together in a single file, which was messy. So this file automated the entire cleanup process by extracting the inline CSS and merge it into a single global style sheet and dedicated CSS files. It separates JavaScript logic into dedicated JS files. It organizes assets, moving images to a central folder. And finally, it moves all the HTML files into a templates folder, ensuring the code follows the industry standard MVC pattern. App.py is the heart of the application. It defines all the routes for the portal like the home page, TIN verification, and registration services. It uses Flask render template to serve the HTML pages dynamically from the templates folder. The templates folder directory contains all our HTML files. Because of the restructuring, these files are now clean and focused only on the structure of the page without being cluttered by hundreds of lines of styling or scripts. The static folder houses our CSS, JavaScript, and images. For CSS folders, it contains the styling for our premium design system. These are all global CSS and dedicated CSS files for each HTML files. So for our JS or JavaScript folder, it contains the interactivity for each page. And for images folder, it stores all the branding and UI assets. By separating the concerns this way, the app is much faster to load, easier to debug, and ready for future features like database integration or user authentication. Now, let's try to run the app by typing python app.py on terminal.
Welcome to the live browser demonstration of our PorTaxPH platform. In this part, we will walk through the happy path of a user registering for an account, highlighting the specific human-computer interaction concepts we applied to solve the usability issues of the old system. So here, immediately on the dashboard, you will notice we replaced the old system's hidden cluttered drop-down menus with this clean card-based layout. So this applies Hick's law by reducing the overwhelming numbers of choices down to these primary actions. So significantly lowering the user's cognitive load. So we also applied Fit's law here. So by turning the main navigation into these large high contrast targets, they are much easier for users to click, especially on mobile devices or for those who are not tech savvy here. So let's initiate registration. As the interface transitions, notice the indicator at the top of the screen. So let's go back first in the desktop view. So in the old system, users might felt lost. So by adding this progress bar, we implemented the script, the principle of observability or visibility of the system status. So the user always knows exactly where they are in the multi-step process. In the step 1, users select their category. So we utilized recognition over recall by using familiar terms and clear subcaptions instead of dense legal tax jargon. When I hover in individual or as non-individual, the system provides immediate visual feedback by highlighting the card with a blue border and shadow, confirming the system registered my actions. So when I click this as an individual, this triggers our terms of service model. To ensure the users actually acknowledge the terms, here, we introduced a physical constraint. So the agree button remains unlocked, disabled, until the user checks the box preventing accidental or blind progression. Here. So, moving on to step 2, we heavily focused on error prevention. So in the old ORUS, the users could easily submit conflicting forms. Here, the form fields are dynamically mapped to the user state using JavaScript. If I select use without existing thing, the transaction dropdown unlocks. But if I select with existing PIN, the system logically disables the dropdown and clears any state data. So, for example, I click this option, then I click I switch to existing data. So this will be lost. This state will be lost. So take a look. Yan. So this continue button acts as a gatekeeper, remaining locked until valid conditions are met. So here, this is locked until I select a transaction type. Yan. So let's try with existing PIN, then continue. Yan. Finally, in the detail step, we implemented recoverability through real-time inline validation. Instead of waiting to hit submit to find out an email is formatted incorrectly, the system provides immediate localized feedback. So for example, if I forgot at symbol in the field, the field instantly outlines in red and provides a clear recovery instruction, allowing the users to fix the error seamlessly. Yan. So please include an at. Then mobile number. So if I put this put an incorrect format of number, for example letter, string, or sobra or kulang na number, hihingan tayo ng tamang format. So makikita naman natin dito yung tamang format. So 9. Yan. So upon completion, the system presents a clear success state. So concluding our friction-free happy path of creating an official BIR taxpayer identification PIN number. So let's let her know. Yan. Also, we can take a look at other parts of our system, like here in about page. Very pleasing siya sa mata. And very responsive din sa mobile. So yan. Let's refresh it. Yan. And frequently asked questions here. Yan. Very easy to use. And our login page. So ito ang itsura niya sa mobile, and ito naman ang itsura niya sa desktop. So as you can see, it is very responsive. Same to the other forms, permits and compliance. Ayan. Update details. So most of the functions here redirects the users to the official BIR site, which is similar naman dun sa ORUS, sa original na registration site natin. So here we just focused on creating an account as a new taxpayer and official tax record. So thank you. In our third and final part, we will compare at least 3 of our fully coded web page directly against the original ORUS web design. We will explore what happened on these specific pages and detail the improvements made, such as resolving the ghost scroll bars, fixing circular navigation loops, and enhancing overall mobile responsiveness.
So now for the final part of our presentation, I will be comparing the original ORUS website with our redesigned system. In this segment, I will highlight the key differences between the two interfaces and explain how our redesigned system improves usability, navigation, and overall user experience. I will also demonstrate the mobile responsiveness of our system to show how it adapts across different screen sizes. Okay, so starting with the homepage, we can immediately notice a difference in layout and overall presentation. The original ORUS interface appears more crowded, with dense text and less visual hierarchy, which may overwhelm users, especially first-time users. So as users scroll through the page, it becomes harder to quickly identify the main actions they need to take. In contrast, our redesigned homepage focuses on simplicity and clarity. We implemented a grid-based dashboard using Bootstrap, where each major function is presented as a card. This allows users to quickly scan the page and choose their desired action without confusion. We also ensured proper spacing, alignment, and consistent styling to reduce visual clutter. This improvement follows the HCI principle of mapping, where the relationship between the interface and the user actions is clear and intuitive. Users can immediately understand what each option does just by looking at the layout. We also improved visual hierarchy by emphasizing more important elements, making the interface more user-friendly. Now, let's take a look at the About page. In the original ORUS system, the information is presented in a long paragraphs, which can be difficult to read and process. This type of layout increases cognitive load, meaning users have to spend more effort understanding the contents. In our redesigned version, we transformed the content into a card-based layout. Each section, such as the mandate, mission, and core value, is separated into individual cards. So this demonstrates the HCI principle of consistency, as all elements follow a uniform design style. It also improves readability and accessibility, allowing users to quickly understand important information without feeling overwhelmed. So in addition, the cleaner design helps build trust, which is especially important for government-related systems. Now, moving on to the registration process, which is one of the most important features in the system. In the original ORUS platform, the process can feel complex due to unclear steps, dense forms, and limited guidance. So this can lead to confusion and user error. In our redesigned system, we focused on creating a step-by-step registration experience. We implemented a progress indicator, such as step 1 of 4, right here. Okay, so this provides system feedback, one of the key HCI principles, because the users also know their current position and what to expect next. We also simplify the form layout by grouping related inputs and removing unnecessary elements. This reduces visual noise and improves focus. Additionally, we applied Fitts law by designing larger buttons and clickable areas. This makes interaction faster and reduces the chance of user errors. Overall, the registration process becomes more intuitive, efficient, and user-friendly. So now, I will demonstrate the mobile responsiveness of our system. In modern applications, it's very important that interface works seamlessly across different devices, especially mobile phones. As we reduce the screen size, we can see that the layout automatically adjusts using Bootstrap's responsive grid system. The multi-column layout transitions into a single-column layout, making the content easier to read on smaller screens. So we also implemented a hamburger menu to save space while still providing access to navigation. This demonstrates the HCI principle of flexibility and efficiency of use, ensuring that both new and experienced users can interact with the system comfortably on any device. In conclusion, compared to the original ORUS system, our redesigned interface offers a cleaner layout, clearer navigation, and a more guided user experience. By applying HCI principles such as mapping, feedback, consistency, and flexibility, we were able to significantly improve usability and accessibility. Our design not only enhances visual appeal, but also ensures that users can complete their tasks more efficiently and with less confusion.
That concludes our UI/UX project presentation for the BIR ORUS PorTaxPH redesign. We have walked you through our code base, demonstrated our improved user interactions, and compared our final output. Thank you for your time and your attention.